virtual tour. Today, we are traveling to a very special place, far away north region of Russia, Chukotka, to see its unique floating nuclear power plant. Our speaker is Pavel Kharlambiev, representative of Floating NPP. Pavel, you're welcome. The floor is yours.
Thank you, Anastasia. Hello, ladies and gents. My name is Pavel Kharlambiev. I welcome all of you here on our virtual tour. And I suggest that we start our tour with a short video to brief you in, to give you basic information about this plant. But before that, I have a small question to you. Does anyone know how many floating nuclear power plants are there in the world today? Any guess? Exactly. Thank you. Yes, super. Now, I suggest that we turn out the lights and play back a video. Okay.
Floating nuclear power plant. This is the world's only floating NPP based on the technology used in Russian nuclear icebreakers. A one-of-a-kind, it was commissioned in May 2020. The floating nuclear power plant consists of the academic Lomonosov floating power unit, equipped with 2 KLT-40S reactors, onshore facilities and hydraulic structures. The floating power plant is located in Pevek, a small town in Chukotka, on the northeast coast of Russia. Academic Lomonosov is a flagship project among transportable nuclear units with small modular reactors. Its safety is guaranteed by the Defense in-Depth principle. The power unit embodies a balanced combination of active and passive safety systems. The floating power unit provides reliable heat and power supply to remote areas in the Arctic and the far eastern regions of Russia. This project helps to address Chukotka's key energy challenges. It substitutes the retiring capacities of the Lyubina NPP and the local Chaun coal plant and supplies energy for the region's largest mining companies. The floating nuclear power plant supports Rosatom's commitment to the UN Sustainable Development Goals. It boosts Chukotka's economic and infrastructure development, improves social protection, and helps to reduce CO2 emissions in the region. The floating power plant is environmentally friendly. It adheres to the zero harm principle and prevents 13 tons of CO2 emissions per day. Today, the nuclear industry's main goal is to provide carbon-free and affordable energy.
And we are getting back on track with the virtual tour. I will guide you today. We will see things that you have already seen in much more detail. And now let's have a look at the screen. This is the floating power unit, Entity Beauty. We will be seeing the map next. This is the map of Russia, and we are traveling to the far northeast region of Russia. It's called Chukotka. From Moscow, the Russian's capital, this trip would take 11 hours if you are lucky enough. And from here, from Dubai, this distance is about 8,000 kilometers, which is like take a trip to the shores of Australia, this far. We are, our NPP is in this bay in Pevek, and we are holding the world's record, Guinness World Record, as being the most northern nuclear power plant in the world. We have taken over this record from another Rosatom facility, the Bilibina nuclear power plant. Okay, Now I suggest that we have a look at this small town, Pivek. As you can see, there are green slopes, but in fact, don't let your eyes fool you, because 8 here, they are covered with thick snow. The temperature at winters is about -30. I think you all know what +30 is, but imagine what these people there experience on the daily. The population is about 5,000 if we count polar bears and deer too. The unusual climatic and geographical conditions put a marked imprint on the local life, and a unit, a large-scale unit, just won't easily fit in such environment. Instead, what we really do need is a factory-made and transportable installation. Now we will be seeing Pivek. A couple of words about the region on the whole. It doesn't have any motor road or railroad connection to the rest of Russia, and there is no the energy grid is isolated from the mainland too. Let me show you my apartment. So this is where I live while I am in Pivek. Thank you. Moving on. Now, I would like to point out that by the floating nuclear power plant, or FNPP for short, we understand 3 things basically: the floating power unit itself, the vessel, the onshore facilities, and the hydraulic structures, this mooring pier, in fact, that is holding the vessel down. Next, we will be taking a tour from the perspective of a bird, from the bird's view. We will now see the FNPP site, and we will be moving as if it was in the real life. So we start from this path here. The personnel enters this path into this first checkpoint. This building is called the auxiliary building. And after that, people proceed down this road, down this path, to the checkpoint 2. This is a guardhouse and the transport lock. We are moving past building. This is the typical office building, the office of the Director General, Chief Engineer, and mine too is here in this building. We also have here all the necessary servicing infrastructure. All these, you can see pipelines, conduits, manifolds, many others. We have the water treatment here, and a substation, this structure. And we are ready to enter the mooring pier, which is more than 300 meters long. But we will take advantage of the virtual presence and make it an on time. A small reservation here, Anastasia, could you please zoom in on any of the buildings? I will show you that all buildings there are built on the piles. This is an ordinary way of constructing on a permafrost. Okay, we're ready to move in. Next step would be the floating power unit, Academic Lomonosov. It will appear in mere seconds. Yes, here it is from this close view. This is the basic parameters of our reactor installations, KLT40. The electric power is 70 megawatts, the thermal power 50 gigacalories per hour. To give you explanation of how much it is, I would tell you that this is more than enough to power supply and heat supply the whole Chukotka region, which is 50,000 people. And important mention, the design life is 40 years. So this means that after the expiry of this period of 40 years, we give away this vessel and receive another one. We replace one for another. This is very convenient because it means we need no decommissioning phase, no land remediation, because the nuclear treatment is on board only, and that's it. So very convenient as I see it. Next step is the same vessel from another angle. This red caption here is the name of the ship, Academic Lomonosov in Russian. This vessel was named after a prominent Russian scientist and academician, Academic Lomonosov, which is in English would be Academician Lomonosov, obviously. He made a significant input into nuclear physics, among other things. And next, we will see a short video of transportation, of how this power unit was transported. As you might see, it cannot travel on its own. It's being towed by tugboats. It was constructed in St. Petersburg, and after it made a long sea trip over 9,000 kilometers around first Scandinavia and then Northern Ocean, with only one stop in Murmansk in the northern Russian port for fueling. While it was towed, it got itself into a storm, but of course survived it. It was like Mother Nature give us a stress test even before we started our operation. And next would be the layout of the floating power unit. Important thing here, the length is 140 meters, which is twice as long as the longest aircraft in the world, Airbus 380, with 2 decks. I think you might know it. Next thing, which is I'm really proud of, is that we have 2 reactor installations within one unit. I can hardly think of any other power units in the world with 2 reactor units, reactor installations in one. But they are located on each board, here and here. And another interesting thing, the living module. In the rear part of the vessel, it takes 4 stories of superstructure. Our personnel, operating personnel, and the crew on board with us. They live on board. Moving in. And here I will show you how it is secured to the pier. You see these 4 blue crate-looking devices with these 4 supports. They are securely holding down the floating power unit to the mooring pier. Also, these hydraulic structures protect the floating power unit from drifting ice, sea disturbances, and even tsunamis with waves up to 7 meters tall. A couple of seconds. Okay, next step, the main control room of the power unit. If the reactor could be considered as a heart, then the main control room is the brain of any power installation. The key person here is the ship supervisor, who is in charge of all the processes and all the signals that flock down this room. They are being controlled and monitored 24/7. Also, we have here 2 reactor control engineers for one power installation on the left board, and on the right board, it's Unit 2 reactor control engineer. Also, electrical mechanical engineer is set in between them, and we have dosimetry on the left, who is responsible for the radiation monitoring all over the plant, also 24/7. I'd like to ask you a question now, if you don't mind. You can see all these people, the members of this room, are not wearing hard hats, but we are a nuclear hazardous facility after all, and people normally would have to wear hard hats. So the question is, why do you think these people are not wearing hard hats, helmets? Any ideas? Okay, I would raise our stakes, and I'll give a special souvenir to a person who gives me at least a variant. No? Why are they not wearing helmets, hard hats? Any ideas? No? It's because the hat might fall off the head and hit a button. This wouldn't be too much of a drama or a disaster, but still it's not desirable. That's why. I think we can move on. And this place is a captain's post. This is the place where our captain is performing his duties, and also he was here while during the towing process. This is something that differs us from other nuclear power plants, because we have captain and they are not. All this marine naval staff, like captain's chief officer, the sailors, and other naval crew. And by the way, this particular place has the most picturesque view, with all these windows open, comparing to any other premises on board. Okay, moving on. Next point would be the refueling hall. This place is this huge room is needed for refueling our nuclear fuel. As you know, we use uranium fuel, and the period of fuel campaign is 4 to 5 years, which means that every 5 or 4 years we need to unload the spent fuel from the reactor. Reactors are under these red caps. And to store it, to place under this platform, this is spent nuclear fuel storage. Using this crane, we unload it from the reactor and put it into the storage. And the fresh fuel would be immediately placed through these openings, right directly into the reactors. Next view, please. Okay. The next view would be the 3D model of our reactor installation. I will briefly tell you how it works. The installation consists of, in the first place, the reactor, walled vessel with a chain reactor inside, and the chain reactor makes the overheated water go to the steam generator, where we convert water into steam over high speed. Then this steam goes down to the turbine and rotates the turbine, and that's basically how we generate electricity. I will not tell you about all these systems and safety systems on the list and the components. I will tell you that using this KLT-40 installation, last year we generated 160 million kilowatt hours of electricity. How much it is? It's like 15 million years of work of an energy-saving bulb straight. That's how much. And we will be going back to the refueling hole. Now we are looking at it from another perspective, from the platform. So the spent nuclear fuel storage is beneath us. We store the spent fuel first underwater during 3 years. And after that, we put this spent fuel into dry casks. And our reactors, which are under those protective caps, are made of strong steel, low-alloy strong steel, as well as the steam generator, the pipelines made of titanium alloy, and this particular installation, which is called KLT40, belongs to a family of reactor installations that we have been using at our nuclear icebreakers. The history of their use is about 400 of reactor years in safe operation. That's why we rely on them so much. And by the way, Rosatom is still the only one operator of nuclear icebreakers in the world. Maybe you know it. Anastasia, could you please fast forward? Yep. Speaking about the safety, we implement the defense in depth principle. We have 5 barriers on the way of radioactive particles to prevent them and don't let them escape. The first is the fuel composition, the integrity of the fuel pellets. Next one is the integrity of the fuel cladding, the covering of a fuel assembly. Number 3 is primary circuit, the integrity of the installation itself. And number 4 and number 5 are the 2 thick walls of the containment. And we are done with the visualization, and another step would be the turbine hole. The turbine hole is the place where we actually produce our power. We have here the turbine, this thing here below, and the generator, this blue-gray thing. As you can see, the arrangement is quite dense comparing to their other turbine holes at other plants. Basically, from here, the steam goes from the reactor, rotates the turbine, which is actually a shaft, a cylinder with multiple space on it. The turbine rotates generator, and this is how the electricity is generated. Now, by the way, the speed of rotation of our turbine is 3,000 rotations per minute, which is at least 2 times as fast as a common washing machine. Now we are moving on to the next point, and just a couple of seconds. Okay, and now I'd like to show how personnel lives in makes its pastimes. In the rear part of the ship, we have accommodation rooms. This is a cabin, a typical cabin. We have a large number of such cabins on board. This is where they work, and this is the very place where they live, where they stay while on rotation. Yeah, by the way, we are working rotations. Yeah, we're down here. Next, we will be seeing our canteen and the cookhouse at this time. By the way, they are cooking perfect pastry. Come check that out if you're a fan of this kind of products. it's very convenient to have a canteen on board. So again, people don't waste their time going somewhere to have lunch. Everything is right here. Next, please. This is a sports hall and a gym. Gym is one door next to this gym for those who want to stay fit. Also, we have a ambulance for the first aid, just in case. Next, we will be seeing the conference hall. This is where we hold all our meetings, virtual conferences, and if you decide to visit us, this is where you will be sitting with us, of course. Now, I suggest that we leave the floating power unit, breathe lungful again. We are on the open deck. This part here is the outer part of the refueling hall. And we have, I think, one more minute to fly over. I would like to say that the floating power unit is not only about generating electricity and heat, but also we contribute significantly to the values of sustainable development. We help the local communities and the region to fulfill their programs of infrastructural development. We help to boost economy, we create jobs, and of course, we help to protect the environment. We prevent the emissions of 30 tons of CO2 daily. That's what we do. And another important thing, that Rosatom never stops evolving. We have only one nuclear power plant so far, but others are yet to come. And we will be using new and advanced technologies with a new reactor of the Ritum. That's another type of reactors. And at this point, I have to say that we are coming to an end. Thank you for your attention, for your interest. I think that's it. Thank you very much. Nice to see you.
Please switch on the light, colleagues. Okay, Pavel, thank you for your wonderful presentation, dear ladies and gentlemen. I hope that you've enjoyed it as much as I did. We would really much appreciate any of your feedback, ideas, maybe comments on our tour or about floating.